Okay, hello everyone. Today for this next mini tutorial, we're going to take a look at kind of where some of the design ideas for Helix came from, and in particular how they related to some of the use cases that were identified early on in this project. My name is Brian Palmentier from the National Renewable Energy Lab, and in some ways this presentation is a little bit different than many of the recent ones because it's kind of a history lesson as opposed to a how-to lesson. But I think that history is relevant for understanding where we've made it to with Helix today. Let me make sure my slides can advance. Apologize for that. There we go. So back when we started this project, we didn't have the name Helix, but we knew we wanted something that could take a lot of different aspects of the modern power and energy systems and be able to co-stimulate them at scale and provide usability and scalability for that. But the reality is that's about all we had in mind. And so the real question is, what exactly do we want to put together with Helix? What do we need to build? And so as the sort of flow chart is described here, and I'll highlight what we're talking about in a second, but to first order, we started with a number of existing tools from many of the labs involved in the team. Here at NREL, we built a co-simulation framework for transmission and distribution with a market focus. At Livermore, the FS-Kit tool, our tool is called iGEMS. The FS-Kit tool had been used for a number of different dynamic scale simulations with communications. And then Phoenix was a fairly generic co-simulation framework, but as we looked around at the needs that we had identified for Helix, we realized that those were probably not quite going to cut what we wanted longer term. So the next step, what we did, and sort of the focus on this call today, or this part of the mini tutorial, was to take a look at a number of use cases and to say, okay, well, what do these use cases tell us that we really need to do within this new platform? And then we'll talk how that led to the platform design, and that became the nascent TDC tool, which has now become branded and named as Helix. So these were the original 12 use cases. Since these slides will be available, I'm not going to go through them all directly, but I think there was a number of observations that were kind of jumped out as we put together this original 12 use cases. The first one was we certainly were covering transmission, distribution, and communication. Here's the highlight of a lot of the pieces that we're looking at transmission, but it's important to recognize that not all of these use cases necessarily included all these components, so flexibility was a key. On the distribution side, or distributed energy resources, you can see a lot of the different use cases needed those, but not all of them, which is also quite relevant to consider. We don't necessarily want to fix ourselves to an architecture that forces those. On the communication side, there were fewer in the original, although if you think about it, many of these use cases do have the sort of optionality around communications, similar to what was just described by Phil in terms of filters. The ability to, maybe the core power systems problem doesn't necessarily have the communications in it, but the way that communication provides, for example, signals out for prices to distributed energy resources in item number 2, that protocols and timing can matter, and the optionality to include the communication is relevant, even if it wasn't necessarily directly included in the use cases you look through it here. The other big observation is that there's a very wide range of sort of time scales and applications that sort of fit in here. Things from very fast transient scale questions up to longer term reliability and pricing, steady state types of questions, and everything in between. And these are just for the 12 use cases. And so we took all those and laid out a bit more detail for this giant mess of spreadsheet, which obviously you're not going to be able to read here, but was our starting point from which we started to work. And to make this one a little bit more tractable, I made a word cloud of all the different pieces here. And you can see the transmission, distribution, and communication were certainly big themes, as well as large scale, medium, and small scale are all included in here, and lots of different time frames, as well as a number of different paradigms. And so clearly flexibility was a key driver, but we wanted to take it a bit further and understand what would we really need in terms of requirements driven by these use cases. So we actually had a workshop here at NREL where the development team, pretty much everybody you've heard from here, as well as a couple others, came and we outlined kind of what is it we really have to have and what is it we'd like to do, and understanding the core infrastructure of what would become Helix. Part of that was summarizing that unwieldy table I showed you briefly in a summary, where each of these use cases, admittedly in a slightly different order, is captured, and then we focused on three key areas we wanted to make sure we could cover. One was on the domain. You can see, as I mentioned before, that many but not all the use cases covered each of the different domains. Of this original 12, almost all of them did have a transmission piece, but we've since then realized use cases where it's just distribution and communication. Distribution was fairly common, communication was included in some, markets were included in some, and there's sort of an implicit recognition of different levels of load modeling and different sort of controls as part of those communication paradigms. Another thing that sort of jumped out, as I mentioned before, the different timescales. You can see these are fairly widely scattered as well. And somewhat consistent with the filters discussion we just had, we came to realize that the communications simulation had a number of different ways that could be done. Some things really just required some reasonable recognition of latency or other sort of high-level packet dropping, or so it's very high-level sort of statistical style losses, as opposed to a few really needed packet level. What is your protocol? How much overhead is there from exchanging TCP/IP versus UDP packets? Those types of details. We wanted to make sure we could support both of those paradigms within the Helix development. And so this led us to a series of must-haves. The top bullet's basically what we've been talking about, and the second one is sort of capturing more specifically the types of timescales, with a key highlight that unlike power flow or many energy processes that are continuous and then might be modeled using time series of various types, or as dynamic sort of differential equation styles, the communication component drove a need to make sure we're compatible with discrete events as well. So the combination of those was a really important driver. And then another one was this sort of ease of use. So the point of the co-simulation was to really stand on the shoulder of giants and take advantage of existing tools. So let's make sure it's easy to include those different tools from lots of different sources, all the different stakeholders. In addition, the scalability was a big driver. We realized that one of the early efforts that I don't have the slides on here, but we did some comparisons with other co-simulation frameworks, FMI and HLA, and as well as the existing ones we had within our labs, and realized that tomorrow's problems that we were therefore building co-simulation for today are at a larger scale than anything that was out there was able to support. And so particularly at the very high end, we realized that on the order of 100,000 federates would be useful to look at some of these exciting up-and-coming problems. At the same time, we wanted to make sure we could run on small systems. That's actually a limitation of a few of the existing platforms that have been built in this space. We want this to be able to run just for that really simple little test case, as well as for these much bigger systems. And so that sort of led to this next bullet of the different compute platforms. We want something that, as I know I think a lot of people are doing today, be able to run on your laptop or perhaps a workstation, but also something that could take advantage of the high computing architectures for these really large scales. And then the focus on usability, at least for the research grade, so we can provide pieces there, documentation. So these were the must-haves that were identified within this process. And that led us to this design that I believe you probably saw early on in some presentations talking about Helix. But we'll kind of talk through this just briefly. The need for cross-platform and scalable support led us to the need to have these multiple different backends, initially focused on ZeroMQ and MPI, MPI being the highly scalable one, but ZeroMQ being the flexible cross-platform choice. A lot of what you've heard discussed in terms of the API is really captured in this application layer and the core layer. A lot of the details there were being sketched out and now are being in practice. And on top of that, we recognized a number of different simulator types. We want to make sure that those are being supported well. And then something that's actually still in the process of being refined as we work towards future versions of Helix is further improvements on the user interface. We'll have additional tutorials on those, as well as additional conversations with many of the folks on the call to start to identify things like automation, configuration, standardization of how these things all interconnect, beyond just what is available now sort of to the development community through the APIs and available to a slightly broader community through the examples. So one of the key things that came out of this also was the recognition of the types of values versus messages, types of data that are being transferred. And this is where the idea of 3 types of federates came up. value federates that would be exchanging physical values, message federates for things that are normally sent over communication systems. You've heard deeper dives on those before, but the mental construct that you may actually have the same data being sent in two different ways, one for the physical simulation to make sure your power flow converges, for example, and a separate, which would be a sensor-based version of, say, those voltage and current measurements that are then used by a management control system. You might end up with similar data going over value and message federates. At the original design, we had actually thought of message filters as a separate federate type. But as you just heard from Phil, we evolved that to realize that filters have a larger opportunity here. And so we've now pulled that out as sort of a federate, but really kind of a portion of the core to be able to manipulate data in transit and to be able to handle, lossy channels as well as delays. And then the key is to make these all consistent and fairly easy to use under the hood. So at the end of the day, sort of the summary slide, you can see we've got this, we were able to use the use cases to inform the platform design as well as our experience, which then led to this now growing series of Helix releases, including where we're at now with the beta and the very soon upcoming 1.0 releases, and then looking ahead to some of the future pieces. High-level summary requirements, these were all driven by these use cases to start with. We started with those 12 use cases, and they identified a need for the scalability, the class platform, and the modularity, the ability to use existing tools, and lots of different simulation types. The one thing I didn't mention that did also come out of this was the realization that we wanted to support coiteration or tight coupling between federates for convergence on the physical values especially, and that was something else that was driven by a number of the use cases, particularly in the dynamic space. And so with that, I think we have a few minutes for some questions, and also point you to there is a paper, a conference paper that covers a lot of the thinking and a little bit more depth on the history of this connection. Any questions?
Excellent. Well, thank you, Brian. Appreciate it.